printing Fibonacci series using recursion. I think you all are familiar with this series 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. The first two digits of the number are given 0 and 1. So when 0 is added up with this 1, the third number, this one, is generated. The 1 in the second position and the 1 in the third position sum up to give the fourth element, that is 2. That means 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, and so on. Every time to get a result, we have to add the previous number and the previous of previous number. That is, to get 5, we need to sum up the previous value, that is 3, and the previous of previous value, that is 2. That is 2 plus 3 will give us 5. So first of all, let me index this series as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So this is the index of each and every Fibonacci term. So for that, let me write down like this. So when index is 0, we need to call a function with the value 0. At index 1, it will call a function with the value 1. So for the first two index, better to say for the first two function call, the function return the same value as its argument. So in the first case, f of 0, that is 0 is the argument, so it will return 0. In the second case, here it is function of 1, 1 is the argument, so it will return 1. And for the rest of the condition or the rest of the index, look what it happens. Now look what happened at index 2. So at index 2, we need to find the function of 2. That means we require the function of the previous value and the function of previous value, that is 0. From the above step, f1 is 1 and f0 is 0. So 1 plus 0 is 1. So f2 becomes 1. Now at index 3, we need to find the function of 3, that's main function of the previous value, that is 2, and the function of previous value, that is 1. So from the above step, f2 means 1 and f1 means 1. So it will be 2. So look at the series. At index 3, the Fibonacci term is 2. So we have to calculate all remaining steps by this procedure. So think what we are doing in the first two steps. Suppose I am representing index as I. So when I less than equal to 1, it is returning the corresponding value, that is I. So when the value of I is 0, it is returning 0. When the value of I is 1, it is returning 1. So this is the first condition we are getting from the first two steps. And what can we conclude for the remaining step? So in the else part, we can write like this. For each and every step, we are performing f of I minus 1 plus f of I minus 2. So this sum will be returned for rest of the case. Let me write down the program for you. First of all, let me define a function, say Fibo, and the argument is say I. The first condition is if I less than equal to 1, it will return the corresponding I. Else, it will return function of I minus 1 plus function of I minus 2. Sorry, it will be, the function name is Fibo, so it will be Fibo. This will be also Fibo. I minus 2. That's all for the program. Now the main code will be like this. To maintain the index, we need to run a for loop for I in say range 10. Suppose I want to display the first 10 Fibonacci term of the series, so that's why I have written 10 over here. You can also take the user input, and from within this loop one can print and call the Fibonacci, the Fibo function with the argument I, and this end is for printing the series in horizontal fashion. Let me run the program. Look, here is the output 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. So these are the first 10 terms of the Fibonacci series. So this is the technique how to construct a recursive function. First think about the base condition and then the recursive condition. Some recursion exercise for you. Calculate the sum of number from 1 to n. Find the sum of element in a list. Consider that a list contains all integer number and find the sum of without using any library function. Next, convert a decimal number to binary form. Write a recursive function to reverse a string. And the last one, anagram. Anagram are words made up of all the characters present in the original word by rearranging the characters. Example, anagram of the word TOPR, TOP, TPO, OPT, OTP, PTO and POT. All combinations of character within the word. So write a program to accept a word from user and generate all anagrams. So this is all for this video. If you have any problem, feel free to write me. Thank you.